In this lesson, I'm going to introduce you to doing data analysis, not using Excel, but using Python, a real programming language, in particular with Python notebooks. Now, why bother with using a computer programming language like Python to analyze the data? Why not just do it all in a spreadsheet like Excel? Well, many parts of the world, they do all their data analysis in Excel. It's done by a lot of economists and by government departments. But there are very major advantages to doing it in Python. One is handling very large quantities of data. If you've got like 20 data points you need to plot, then Excel is perfectly fine. If you've got 20 million or 20 billion, then it's not so good. And many modern experiments will have millions, billions or trillions of data points. I'm involved in the SkyMapper Sky Survey, and that's generating terabytes of data a night. There's no way you can handle that in Excel. Secondly, Excel is really rather crappy and primitive plotting. It doesn't give publication quality, nice looking plots that you can actually use in a paper. So if you want to get nice quality plots with more options and a better formatting and so on, then you're going to have to use the programming language. You can't publish Excel plots. Also, Python's much more flexible. If there isn't the function for what you want in Excel, you're kind of stuffed. But in Python you can add in any number of packages and libraries or write your own. For example, a proper fitting of lines with errors which aren't all the same, and working out what the uncertainty in the gradient is. That's something you can't do in Excel and you can do very easily in Python. So Python, being open source, much more flexible, gives you a lot more power to do different things. So for all these reasons, it's part of your toolkit as a physicist, or in fact any form of scientist, to be able to analyze data using something like Python. And it's a very useful commercial skill. Most data scientists will use Python or other similar languages, and it's very widely used in the sciences of data analysis. I do all my own data analysis in Python by and large. So, we're going to introduce you in particular to a Python notebook. Now for this you don't want to use glowscript.org, you should be actually using Anaconda Python. So if you start up Anaconda Navigator, and you'll see Jupyterlab. So rather than using Spider, you can use Spider for data analysis, but Jupyterlab is specifically designed for playing around with data. It's what's called a notebook. So if we launch it, it will open a new tab in your web browser, whichever is your default web browser. In my case, that's Google Chrome. Okay, so in the left here, you have the which folder you're in, and to the right, you decide what you're going to launch. The first step is to pick which directory you're going to be in. Like if you're going to do all your analysis on the desktop, then you should move to the desktop. I'm going to go to Physics 1101 folder and lessons, maybe workshops, and workshop 6. Now this is important because you're going to want to read in data, and you want your data to be in the same folder on your computer that your program is. So when you download data from Wattle or you type in a Excel document or whatever, check where you're downloading it to. Is it going to downloads? Is it going to the desktop? And wherever it is, move it to the same folder you're going to do your work in. It's often worth creating your own directory somewhere, maybe on the desktop, and putting everything in there. Okay, so we're now in this Workshop 6 folder, and we're now going to start up a notebook. So if I click here, it starts up a notebook. Now what is a notebook? A notebook is a Python program, but it's broken up into little pieces called cells. So what you have here is a cell, and you can put a few bits of programming in there, and then run that cell, and then have another cell with more programming in it. What this means is instead of running your entire program every time, you can run little bits. The benefit of this is mainly for analysing data. You can have a first cell where you import the libraries you need, and then you don't need to worry about it again, it's been run. Then you can have a cell where you load in your data, and then it's been done. The data's there, ready to play with, and then you can try different things. You can play with it this way, play with it that way. You don't need to bother going back to reload everything. You can also document what you're doing. So it's actually like a written notebook. So this cell is a code cell, but we can change it to a markdown, which is a text cell, and say, just put text in here. If you put a slash, it turns into a title. So if I type something here, now to run a cell, click in it and press the Shift and Enter or Shift and Return buttons on your keyboard at the same time, and that will run it. If it was a markdown cell, that just means it comes out nicely formatted. For code cells, it will run it. Okay, so I'm going to start off by loading some packages. Python has many different add-on packages, some of which are built into Anaconda and some of which are not. And this allows you to have more functionality. We're going to need two packages. One is a plotting package called matplotlib, and the other one which is a data analysis package called pandas, for Python data analysis, I think it says. So let's see. Import is the command to import one of these packages. Import pandas. I'm going to call it as PD. You can always import something and give it a shortened name, which will save you typing later on. So that means we're going to have PD as shorthand for pandas. And from matplot, sorry. So what I'm going to do is matplotlib is a plotting package, and it's got a sub package called pyplot, and I'm giving that the shorthand name plt. So these, you can just treat them as magic incantations, just copy them to the top of any notebook you're doing. And now I'm going to do Shift Enter in the cell, Shift Return, and you'll see here, it'll give a little star for a second while it's running, and then it will change into a digit once that cell has been run. So those packages have now been imported, and we can use them without any further bother. Now I'm going to read in some data. But the data we're going to use is in the form of an Excel spreadsheet, but pandas can read in many different formats. And these are actually the data that got Brian Schmidt's Nobel Prize. These are a whole group of supernova exploding stars, and this is the redshift of the supernova, which is how much the light from them has been shifted while it's travelled to the Earth, and the distance to the supernova and the uncertainty in the distance. I haven't given an uncertainty in the redshift because redshift can be measured very accurately, but distance is very hard to measure and has a very large uncertainty. Okay, so that's a spreadsheet. If you're doing this in your own lab, you can just type in the spreadsheet, and what we're going to do is import it. So what we're going to do is we're going to import it and store it as what's called a data frame. I'm going to call this whatever you like. I'm going to call it data. And we're going to use the pandas command, which we're going to shortcut with PD, because up here we shortcut the pandas as PD. If you just had import pandas here, you could type pandas dot whatever it is. And we're going to use the read Excel command to read an Excel spreadsheet. We've typed the name of the spreadsheet. I called it supernova-data.xlsx. So put that in quotes. supernova-data.xlsx. We have to get the capitalization right. If I hadn't put the capital D here, it wouldn't recognize it. And if we try that, Shift Enter again, and it's run. It's given a message that we don't need to pay any attention to. And we can check that it's been loaded by typing data.head with open and close the brackets after it. And what this does is it shows us the header and the first few lines of whatever we've read in. Okay, so it's read in the data, and here are the first few lines. It's got the headers. So if you look back at the Excel document, you see I'd given it headers, SN for supernova, Z for redshift, D for distance, and uncertainty for uncertainty. And it's read them in, it's got them as headers, and then it's got the data and it's plotted the first few lines. If we want to plot a particular line of the data, we can print Let's say we wanted to plot the names of the supernova. We could plot data.sn. So the name of our data dot whichever column we want, and Shift Enter, and it will print out the first column of all these things. So that's how we start up a notebook and how we read in the data. I should also mention we can rename the data. If you click up here and right click, we can rename the notebook. We don't want everything called untitled, so let's call it Lies Supernovae. And it's in the same directory it's going to be saved at that we've already moved to. And you can now see, here it is, in the list of all the files in the directory.